Reddit's r/place. Millions of people, billions of pixel placements, one canvas, and I wanted to scrub through the whole thing like a YouTube video locally on my laptop at 1,000 times speed, so I built one. This is Replace, the entire r/place dataset, 2022 and 2023. Reddit gave every user 1 pixel every 5 minutes, so anything you see here had to be coordinated. Zoom out and you can pick out the borders between communities, some negotiated, some contested. Zoom in and you can read the flags, the inside jokes, and the art that took communities days to defend. The bottom is a seek bar. Drag forward and scrub the event in real time. Drag backward and the artwork comes apart pixel by pixel. Every defended border, every overnight wipe in reverse. Playback speed goes from 1x to 1,000, so the whole event compresses into a few minutes, and you can finally see which corners of the canvas stayed contested the whole time and watch XQC's void quietly recycle half of it.
This is good! This is good! Guys, focus! Focus!
Under the hood, it's 2 pieces, a Rust preprocessor that chews the raw Reddit CSVs into a browser-friendly format, and a WebGL viewer on the front end that streams it back. Let's get into how that works, because there are some genuinely fun problems in here. Reddit publishes r/place as a pile of gzipped CSVs, hundreds of millions of pixel placements. And here's the catch. The order is a mess. The file numbers don't track time. File 12 might cover an earlier moment than file 3. To replay this thing in chronological order, I have to globally sort everything by timestamp first. But the dataset is way too big to load into RAM and just call .sort. So I use an external merge sort, a classic two-phase deal. Phase 1. Open each gzip file, decompress it, sort that one chunk in memory, write it back out as a sorted intermediate. Do that for every file. Phase 2. Open all the sorted intermediates at once and do a k-way merge. Pull the next record from each, push them through a min heap, and pop them out in timestamp order. The heap stays tiny, 1 entry per file, so memory's flat no matter how big the dataset gets. Classic external sort, the kind of thing they teach you in databases class, and then you never use it until one day you do. Once I've got a globally sorted stream of pixel placements, the next problem is seeking. If a user drags the seek bar to hour 47, I do not want to replay 47 hours of pixel placements to get there. So I borrow the trick every video codec uses, keyframes. Every 3 minutes or every 200,000 pixel updates, whichever comes first, I dump a full snapshot of the canvas to disk. That's a checkpoint. Between checkpoints, I write a delta file containing just the pixels that changed. And the delta format is tight, 9 bytes per pixel change, 4 for the timestamp offset, 2 each for X and Y, 1 byte for the color index. That's it. When you seek, the browser grabs the nearest checkpoint behind you, then replays the delta forward until it hits your playhead. Fast seek, small files, no big video to decode. Quick tangent on a thing I tried. The canvas is palette indexed, 1 byte per pixel, and PNG has a native indexed color mode. Felt like the obvious format, smaller files, free compression, browser decodes it for you. Turns out PNG in the browser is slow, just not where I expected. The native decoder is fast, but it runs off thread and never hands you the pixels back. You pay a canvas round trip and a per pixel remap to get the data out. Decoding in JavaScript skips that, but now the decode itself blocks. Either way, tens of milliseconds on the main thread, every checkpoint, and at high speed, that's a visible hitch every few frames. So I went the other way, raw.bin files, literally 1 byte per pixel, no header, no decoder. Fetch it, hand it straight to a WebGL texture, done. And the kicker? HTTP level gzip on the wire gets transfer sizes basically equivalent to PNG. Same bandwidth, 0 decode time. The renderer is WebGL 2, and it's doing one specific trick that I really like. The canvas can be 3000 by 2000 pixels. If I uploaded that as RGB, 3 bytes per pixel, that's a chunky texture. Instead, I upload it as an R8 texture, 1 channel, 1 byte per pixel, holding palette indices. The actual colors live in a separate, tiny one-dimensional palette texture. The fragment shader reads the index from the grayscale map, uses it as a coordinate on the palette strip, and resolves the color. So every checkpoint load is 6 megabytes instead of 24, a quarter of the texture upload bandwidth. That's a big part of why scrubbing at high speeds stays smooth. The GPU doesn't even blink at the extra texture fetch. It's basically free. Last front-end bit. At 1x speed, you don't need to prefetch much. The next checkpoint won't matter for 3 minutes. At 1000x, you're burning through checkpoints every couple seconds and any stall is visible. So prefetching is adaptive. The faster you play, the more checkpoints I pull ahead. Each fetch has an abort controller attached, so when you scrub backwards, I cancel the in-flight requests immediately instead of wasting bandwidth. Okay, favorite feature. There's a thing about r/place where no matter what year, no matter what subreddit, sussy Among Us crewmates manage to infiltrate. They are everywhere. So I added a detector. I need to be clear about credit on this one. The detection algorithm is not mine. It's from a project called AmongiAnalyser by Wouter van der Velde. I ported the approach to TypeScript and dropped it into Replace. That's the whole story. Go check out the original, link in the description. That's Replace. Rust preprocessor, WebGL viewer, a bunch of small tricks that add up to a thing that feels nice to use. There's a live version. Links on screen and in the description. Open it and go find whatever you remember being there. Code's on GitHub too. Catch you later.